Okay, the final problem looks a lot like the last problem. A couple differences. Obvious one is there's letters instead of numbers. That's the obvious one, right? We got a couple radicals happening here also. But what's different about the radicals in this problem? Want to put them side by side?
That one's not totally over the...
Perfect. This radical stops here. It doesn't get this inside. So here, if I'm going to erase these marks here, we can see that this bar extends all the way over top of that. So this radical lives inside of this other radical, where this radical stops. So you have radical 1, radical 2. They're separate from each other, being multiplied together. That's the difference. All right. So, and again, they look very closely the same. They're introduced in the same lesson. And you've never seen this before, nor have you seen this. They look very, very close. But they purposely put letters in these problems just to have that difference, obvious difference. So when you see letter problems, they'll be like that, number problems like that. At some point, they'll mix them together. They'll throw some numbers into those and some letters into these, maybe. All right? But just keep in mind that radical inside radical, radical times radical. There's a different structure to the two. Now, once I get that structure established, once again, this is very much like the book does. On test, I always put a raised dot to show you the spot there. But be careful with this root and these powers. All right, the root's over top of the radical piece, so that belongs to the x, y. So this is one of the objects, and this is the other object. What root's on top of this one? 2. A second root. Very good. So the index of the radical is always 2 unless otherwise written. So this one's 2, this one's 3, and of course the powers on x and y are 1 and 1. Okay, so when you see that structure, radical times radical, x's and y's and z's, whatever letters they have in there, and you put all your understood indexes and powers. First power is on letters that don't have powers, a second index when there's no index given. I'm going to create a fractional power out of the whole problem. Okay, so what that's going to look like is this. X is going to be to the 3/2 power. Y is going to be to the 2/2 power. What's 2/2 better known as? 1. Okay. Feel free to reduce fractions when you make these fractional powers. So 3/2 is 3/2, 2/2 is 1. Looking at the blue fraction, these fractions are being multiplied, these radicals are being multiplied, so these things down here are being multiplied, so this times these things. This x is going to be to the 1/3 power, and that y is going to also be to the 1/3 power. So in each case, the inside power divided by the root makes the fractional power for each object. Fractions that reduce should be reduced. At this point, I've got x being multiplied by x, and I've got y being multiplied by y. That's all that affects anything. And all I have to do to multiply x's is the same thing I did in the other problems. I'm going to add the powers. So for x's, what I have to add is 3/2 and 1/3. Can I add 3/2 and 1/3?
No.
No, I have to get a common denominator, right? So if I do 3/2 plus 1/3, common denominator is 6, right? 2 times 3, so 3 times 3. 3 times 2, so 1 times 2. So 3/2 plus 1/3 just makes 11/6. So x is going to be to the 11/6 power. Please make sure it looks like a power. If you write that, you're not trying very hard. Okay, look at the difference in the way I wrote it. That's the good way right there. That's not so good. X, put it way up there, 11/6. Don't make it look like a mixed number. And I should have said that on these also. 3 to the 5/12, not 3 and 5/12. This is bad. This is good. The power is obviously up. All right? So, x to the 11/6, again, we're not using that one. So, x to the 11/6 power, and then for y, we're taking 1 and adding it to 1/3. What's 1 plus 1/3?
7/3.
Try again.
4/3.
4/3. I heard 7/3. 4/3 is the right answer. If it was 2 plus 1/3, it would be 7/3. All right.
Yeah.
1 plus 1/3. And again, if you get a common denominator, that's 3. This would be 3/3 plus 1/3 makes 4/3. Also, 1 and 1/3 is a mixed number, right? 1 times 3 plus 1 is 4. Take your pick how you want to do that. But adding 1 and 1/3 gets you 4/3. I got x to a power, I got y to a power. That's what my final answer is going to look like. So when you have radicals being multiplied, change everything to a fractional power. multiply the common bases by adding the powers, reduce fractions, lowest terms. Your final answer should look like that. X to some fractional power times y to some fractional power. If one of these fractional powers came out as whole, like for example y squared, write down y squared. It doesn't have to be a fraction. You have to put y2 over 1. All right. Sometimes they come out to whole numbers. Not very often, but sometimes. All right. And that's it. You see that? That's what your answer should look like. Again, be very cautious. Radical stops. Radical goes over top of other radical. There are two different kinds of problems. Use the proper technique for each one.